Thanks for the opportunity to present here on the forum. As you said on the introduction, we're going to talk about NFPA 70B, some of the more recent updates, and then we're going to tie that into some of the condition monitoring that we can do on electrical assets to make sure that we're not only complying with the new standard in 70B, but also just keeping our assets safe and reliable. Now, at the heart of every facility, whether it's manufacturing, institutional, commercial, or residential, electrical power systems are the most critical elements of the infrastructure. But unreliable electrical power systems not only cost millions of dollars in downtime and repairs every year, they have the potential to maim and kill maintenance personnel that are responsible for their upkeep. Therefore, reliability leadership has to focus on the preservation of both physical and human assets, because everyone's got the right to a safe work environment and to return home unharmed. So the topics I'm going to cover here today, three of them: NFPA 70B, ultrasound technology, and electrical failure detection. So under the NFPA 70B, I'm going to speak about the standard established by the National Fire Protection Association that provides essential guidelines for electrical safety and maintenance practices. And when the practices encapsulated in NFPA 70B are followed, the resultant benefits is a significant enhancement to worker safety and the reliability of those electrical assets. I'm also going to cover ultrasound technology, a key condition monitoring discipline that has to be the cornerstone of every electrical maintenance program, or EMP. And then finally, we're going to look at some electrical failure mode detections. Looking at some of the things that we can find just going out and scanning switchgear panels, transformers, substations, and the like. But first, a history lesson. NFPA 70B has a long history as the guiding document for electrical maintenance practices, and it was first conceptualized in 1967. And officially in 1975, it became adopted as a standard. And since then, the standard's been updated on a regular 3-year cycle to keep pace with industry needs and safety requirements. The most significant change came just recently in January of 2023. And up until then, NFPA 70B was viewed primarily as a set of recommendations or best practices. But with the 2023 update, those recommendations transitioned into enforceable industry standards. What that means is simple but powerful. NFPA 70B is no longer just guidance. It's now the benchmark that defines how electrical maintenance must be performed. Its scope impacts virtually every aspect of the electrical system maintenance today. So as of January 23, NFPA 70B transitioned from recommendation to a standard, and a standard that can be enforceable. Implementing NFPA 70B will improve electrical asset reliability through the following new information and practices. First of all, it outlines the importance of a structured electrical preventative maintenance program for electrical equipment, including transformers, circuit breakers, MCCs, motors, switchgear, substations, anything. Regular maintenance, and that really just doesn't tie to certain voltages, high voltage, medium voltage, right across the entire spectrum. Regular maintenance ensures that equipment operates optimally and reduces the likelihood of unexpected failures. Failures that could lead to downtime, failures that could lead to costly repairs or safety incidents or worse. The standard recommended regular inspections and testing of electrical systems to identify wear, to identify degradation, or to identify impending failures. These preventative measures, they'll help us catch issues early before they escalate into more significant problems that could compromise the system's reliability or its safety. Additional new info in NFPA 70B 2023 is that the latest version goes into great detail on what qualifications people should have and maintain to safely and effectively inspect energized electrical assets. So essentially, we don't want just anybody walking out there and doing inspections. There has to be training involved, and not just training on the condition monitoring technologies and how to interpret the data, but basic training on how to behave and conduct yourself safely around these assets. So the big change here, inspections only performed by qualified personnel. And then implementing and documenting an electrical maintenance plan. NFPA 70B emphasizes the importance of keeping accurate records. Keeping accurate records of maintenance activities, a detailed log of inspections, repairs, and modifications that allows companies to track the performance and condition of their equipment over time. Historical data is invaluable for making informed decisions about replacements or upgrades and ensuring compliance with industry regulations. But if nothing else, you need to have these records on hand, because in the case of an audit or in the case of an inspection, you need now to be able to prove that you have this EMP in place and that the records are there and accessible and readable by all. Just run through just hit some of the key sections of the NFPA 70B. Section 1.2. So that gets to the heart of why the standard matters. It emphasizes the practical safeguard that comes from establishing a proper condition of maintenance. In other words, it's not just about compliance. It's about creating an environment where electrical systems are both safe and reliable. So this section is going to reinforce the link between proactive maintenance on the one hand and protection of people, assets, and operations on the other hand. Section 4.1.1, it's straightforward, but it's critical. It establishes that electrical equipment must be maintained according to the manufacturer's instructions. Reasoning is pretty simple and straightforward and common sense to me. The manufacturer knows the design, he knows the tolerances, and they know the safe operating limits of their equipment. So by following their guidance, organizations not only complying with the NFPA 70B, but they also protect both the safety and personnel, the reliability of the asset. Then section 4.1.3. So this just addresses if there's an absence of instruction. So addressing situations where the manufacturer hasn't provided maintenance instructions. Well, in those cases, the standard requires that equipment be maintained according to recognized industry standards. And this ensures there's never a gap, whether guidance comes from the manufacturer or from the broader industry. Maintenance practices must always align with proven, accepted methods. 5.1.1. So this section makes it clear that electrical maintenance must only be performed by qualified personnel. Okay, so kind of repeating what I said earlier, but this isn't just a matter of compliance. It's about safety and competence. Qualified personnel have the training, the knowledge, and the practical skills needed to safely maintain electrical equipment. So when we allow unqualified individuals to perform the work, it introduces unacceptable risks to both them, but also the people around them, as well as the systems. And if you think about, well, if we think about the most critical would be a hospital, you know, where if a transformer outage can have a lot more impact on just the person performing the inspection, it's going to have an impact on the people that are in the intensive care unit or people that are on life support systems, et cetera. So it really is critical that proper training's done and only qualified personnel are performing maintenance. Then at the end of 70B, the Annex 1, it expands on the role of reliability-centered maintenance, or RCM. It explains how RCM helps organizations improve both asset availability and operational availability. The annex also outlines specific RCM strategies, practices that align maintenance activities with the actual reliability requirements of the equipment. In short, Annex 1 connects the standard to a structured methodology for maximizing performance, minimizing downtime and managing risk. So that's kind of a recap or a summary of NFPA 70B, the newest edition, which was released in January of 2023. Let's look now at my specialty, which is ultrasound, and specifically ultrasound for condition monitoring of assets and asset management. So at a 30,000 foot level, ultrasound plays an increasingly important role in all asset inspections, but specifically for this presentation, electrical inspections. And first and foremost, it improves worker safety. By allowing inspectors to listen to what's happening inside their closed electrical cabinets, ultrasound makes it possible to detect problems without opening energized equipment and exposing those inspectors and the people that could be in the vicinity to dangers of arc flash or arc blast. It also serves as a powerful condition monitoring and preventative maintenance tool. We can detect arcing, we can detect cracking and corona long before they become visible or lead to failures. And these are all signs of a breakdown in the dielectric material, the insulation of different components in the electrical system. Ultrasound is especially useful during new equipment installations, helping to confirm proper operation right from the start. Another advantage is its flexibility. It can be used in the intervals between infrared scans. If you don't have an in-house infrared thermography program, and if you're outsourcing that either to an insurance company or to a third party, they're not going to be there and on site doing those inspections. Sometimes some places don't do any infrared thermography. Some do them annually. Some do them quarterly. In between those, having an ultrasound program and a qualified inspector that can come in and perform in between, it just fills the gaps and gives you a more complete view of the story. So ensuring that assets are continuously monitored rather than only checked once or twice a year is a big deal. Finally, ultrasound, it aligns with compliance requirements under the new industry standards, supporting a documented EMP, proactive approach to electrical safety and reliability. So for those that are on this call, if you're not really familiar with ultrasound, I mean, everybody knows about ultrasound and we use it. It's used in so many different ways, from cleaning our jewelry to backing up our cars and parking our cars to listening for asset failures. I'm just going to give you a real, and this isn't even a 30,000 foot view. This is a 60,000 foot view. So there's really three classifications, or let's say categories or classifications of sound. The first being infrasound, which is any sound pressure wave that has a repetition frequency below 20 hertz. And we go into the audible range. Now we're talking signals that are from 20 hertz up to, let's say, 20 kilohertz. And then if we go above 20 kilohertz, we go into the ultrasonic range. And so what you'll see as different between the three, if we look at infrasound, that wavelength, as we go higher in the frequency range, the wavelength becomes shorter and shorter. And then we get into the ultrasonic range, the wavelength even gets shorter. And if we go, higher and higher and higher into the megahertz instead of the kilohertz, even shorter again. And what the shortening of that wavelength does is it creates three characteristics. One is distance. The higher we go in the frequency range, the shorter the distance that sound pressure waves can travel through their medium from source to sensor, whether that source be my mouth talking to your ears, or whether that source be corona sizzling away on a high voltage transformer and then being picked up by our sensor. So the distance that the signal can travel can be played to our advantage, because if we're trying to inspect, let's say, a localized section of a substation, but we just want to listen to the asset that we're focusing on. We don't want to be interfered with by other assets which might be nearby. and other sources of ultrasound which might be nearby. So choosing 40 kilohertz as our listening frequency is advantageous for us in that sense. Back to there. Another advantage of ultrasound is directionality. The higher we go in the frequency range, the more directional the signal becomes. And when that signal becomes directional, again, we're not being interfered with by other assets that might be producing ultrasound nearby. So we have distance, we have directionality, and then the third characteristic of sound is its ability to transition from one medium to another, what I term as boundary behaviors. And that's also another element or characteristic of high frequency sound, which plays to our advantage as inspectors trying to find these sources of airborne ultrasound, which are pointing us towards defects in the asset itself. Now, what we've keyed in on at SDT is what we call the 8 pillars of ultrasound. And this really just refers to 8 categories of applications where ultrasound inspection can be deployed to help us have a better understanding of the condition or the health of our assets. So those are mechanical, leaks, lubrication, electrical, valves, steam, hydraulics, and tightness testing. So in each one of these cases, we can use ultrasound to determine the health of the asset. Mechanically, we can listen for friction and impacting and turbulent flow. For leaks from high pressure to low pressure, or vacuum leaks from low pressure to high pressure, we're listening ultrasonically for that turbulent flow. And because of distance, because of directionality, we're very good at using ultrasound to pinpoint exactly where the source of the ultrasound is coming from. Lubrication. So bearing lubrication is, or poor lubrication practices is the single biggest cause of bearing failures. We do have in data centers, we have in all kinds of different electrical assets, we have motors running fans for cooling. Those fan bearings, they need to be lubricated on the right interval. If they're over lubricated, they're going to fail. If they're under lubricated, they're going to fail. What we're doing with ultrasound is we're listening to and measuring the amount of ultrasound being produced by friction in the rolling elements of the bearing. And as that friction changes, we know that the lubrication film is changing. And so we can use ultrasound to guide us to know when to lubricate and how much to lubricate. Finally, the application pillar of electrical, well, that's what this presentation is really about. And so this is the breakdown of dielectric material insulating the transfer electricity through systems. And as that breaks down, it produces distinct characteristic noises, which we can hear very clearly in the 40 kilohertz range. Valves, again, turbulent flow across the valve head tells us whether or not the valve is opened, closed, cavitating, or flashing. Same with steam in a steam trap. If steam is leaking the atmosphere or if the steam trap itself isn't working, we can detect friction, impacting, and turbulence to determine the condition of a steam trap. Hydraulic systems are mostly mechanical, but also some flow, so flow through pipes and turbulence. And then finally, tightness testing. Those make up the 8 pillars of ultrasound, the applications of ultrasound. And if we look at classifying these, if we take the first 4, leaks, valve, steam, and tightness, these help us eliminate or control waste. And if we look at lubrication, valves, steam, electrical, and hydraulics, and mechanical, all of these, by doing ultrasonic surveillance on these asset categories, we can eliminate unplanned downtime. And when we manage all of these application pillars with ultrasound, we have the ability to eliminate accidents. We eliminate accidents because all of our failures are known, they're predicted, or at least anticipated. And we have time to plan for the repair, which means that the people performing the repair are working in a planned, calm manner. They're following procedures. They're not cutting corners. They're not under pressure to finish the job quickly. Therefore, they work more safely, and there's less chance that they're going to be injured or worse. Now, to focus in specifically on electrical inspections, because that last little bit was a kind of a more broad spectrum of applications, but to look specifically at ultrasound and electrical inspections, well, we can use ultrasound to detect low, medium, and high voltage systems, whether it be low-level nuisance corona, high-level destructive corona, tracking, arcing. All of these things are pointing towards an eventual asset failure, and ultrasound helps us discover not only that they exist, but where they're coming from. Ultrasound also gives us the ability to listen to these assets without opening energized electrical assets in the case of electrical cabinets, motor circuit control panels, switchgear, etc. But if we're listening for substations, it allows us to listen on the safe side of the fence, or at least from a safe distance from the asset. So how does ultrasound detect? Well, what happens when we have a breakdown in the insulation material is at the source of and I'll call it a leak, it's not a compressed air leak, but it's still a leakage. And at the source of that breakdown or that leakage, we have ionization. And the ionization forms both ozone and nitrogen oxides. And between the two of these, they combine with the moisture and produce nitric acid. Nitric acid is destructive, and it results in the corrosion and deterioration of the insulating materials. If it's left unchecked long enough, you don't need ultrasound to find it. You just need common sense and good eyesight, because a lot of the times you'll start to see, I'll go back to this slide, you can start to see, I mean, you don't need ultrasound to see that there's corona, this white powder around here. That's the ionization of ozone and nitrogen oxide forming, and it's pretty apparent. But ultrasound being able to detect things early in the P to F curve would have heard this long before it became visible for us. So ionization, corona discharge, the ionization of air really only occurs above 1,000 volts. So if we're working with lower than 1,000 volts, there's not going to be any corona to hear anyways. And typically, corona doesn't produce enough heat to be detected with an infrared camera. So if you're only relying on thermography as a condition monitoring technology for corona, well, you can forget it. You're not gonna see that heat. But corona does produce sounds with peaks in around 40 kilohertz, and those sounds, if you have your speakers turned up, you would have heard that. That's a typical corona sound that we would hear. Now, if we record that sound file with our ultrasonic data collector and then look at it in the time domain, as I've just shown here on the screen, what we start to see is these distinct peaks. And if we were to just listen for them, we can't hear them because they're happening too quickly. This whole time waveform, this is 1 second. So, all of these events are happening in a second. And if we were to bring it into the frequency spectrum, we would see that depending on where we are in the world, that these peaks would either have 50 or 60 hertz deltas between them in terms of time. And that's just showing the line frequency or the carrying line frequency of the electrical system. All sources of insulation breakdown, you just have voltage or electricity trying to find a pathway to ground. So whether it's corona, whether it's tracking, now tracking can occur at any voltage. You'll see it sometimes if you look at an insulator. I should have put a picture of an insulator up here that has tracking on it. It's kind of like, it looks like varicose veins almost, the best way I can describe it. You can see what's happening is that electrical voltage is tracking across the surface, and eventually it's deteriorating the material to the point where you can now have weather ingress, whether it be water, rain, ingress, and in cold climates like we have here in Canada, that turns into freezing and then superheating. And when the water gets in there and then you have mixed heat within it, then it doesn't take long before the insulator breaks down completely. The difference between, if we just flip back to the corona, you'll see these repetitive peaks, and they have a repetition frequency. They're all nicely spaced out. Tracking becomes more random. So you'll see short bursts here, then you'll see quiet, and short bursts here and quiet, and then more short bursts. And this is why also thermography on its own doesn't work that well, because in this zone here, you may have some heat generated, but then it goes quiet for a bit and the heat goes away. So if, depending on when you're doing the scan, you may see heat, you may not see heat. But if you're listening ultrasonically, that's fairly unmistakable. I'm showing progressions here. Corona is early stage. Tracking is the next stage. Arcing is what I would call, so if we were to go mild, medium, hot, or a warning versus an alert versus an emergency. When we start getting into arcing, we're now into an emergency stage. That means that the breakdown of the insulating material has become critical. We have a high current pathway to ground. And ultrasound detects the buildup and discharge of electrical energy. And again, if you're only using thermography, you're going to see temperature sometimes, but not all the time. Just play this. So what you're hearing there is there's changes of amplitude, changes in amplitude, changes in intensity. But man, if you're a rookie to ultrasound, I would, if I was hearing that for the first time, I just say it sounds angry, and nobody wants an angry asset. If we've reached the point of arcing, we're now in the danger zone, and it's arcing that's going on inside cabinets, which can mix with air and then create that arc flash when we open the panel. So when we've gotten to this stage, well, if I'm listening to an electrical cabinet with ultrasound before I open it, sure, I'm going to have a lot more confidence. That doesn't mean I'm going to not use my arc flash, my PPE, but I'm certainly going to have a lot more confidence having listened to the panel before I opened it. That's for sure. So just to summarize on that, some best practices for electrical inspections with ultrasound. Again, I definitely am a big proponent of using infrared thermography, and I'm a huge proponent of using ultrasound. I'm even a bigger proponent of using the two together. I like to say you can hear what you can't see with ultrasound, and with infrared, you can see what you can't hear. So why not cover your bases and use them both? And if you're outsourcing infrared thermography to a third party or to your insurance company, use ultrasound in between their annual visits. If you only use infrared, you're going to miss conditions that infrared can't see. And then finally, once you've pulled that ultrasound data in, you have the opportunity to analyze the sound files using both the FFT spectrum and the time waveform to diagnose specific problems. Couple of case studies for you. So here is an electrical inspection that was done on this transformer here. You can see that most of this transformer is sealed with panels, but we have an area here and an area here which is not sealed. So this is a great candidate for airborne ultrasound inspection. And if we look at the signal that we picked up coming from this part of the cabinet here, and if we look at the we're looking at the frequency spectrum here, and we can see that these events are all lining up as 50 hertz. So we know that this is not in North America. This is somewhere else where the line frequency is 50 hertz. But I can look at these repetition frequencies in the FFT, and I know right away that this is not arcing or tracking, but this is corona discharge. Because the peaks are observed with a delta of 50. I kind of covered that, so I'm not going to repeat it again. The only thing I will emphasize is that this was determined to be destructive corona. And why did we determine it was destructive corona? Because we'd monitored it over time. We might have detected it a few months prior, and now that we've let it go for 2 or 3 months, we can see that the amplitude in the y-axis has become elevated. And so as it elevates over time, we know that we're moving from nuisance corona into destructive corona. The recommendation was to clean the component that we'd isolated and then clean it and then come back and check it again to see. There was no heat being generated by this defect. Here's a commercial insulator, a commercial 3-phase transformer, pretty standard stuff. You drive around any industrial park, you're going to see lots of these hanging around. We've opened the doors up on them. Now we had detected using a contact sensor with a magnet on it, much the same way a doctor might put a stethoscope on your chest. We put a contact sensor on the outer housing, and through the steel, we were able to hear that there was some corona activity present. So a little bit more investigation. We got some qualified personnel to open the panel up for us. And we started on the left insulator. We moved to the middle. And we finally moved to the right. Now, what I'm going to point out for you is if we just look, this is the time waveform. We took a 3-second sound file. If we look at the y-axis, we're scaling to 1,000 microvolts. So this is the intensity or the amplitude of the signal that we detected. If we move back to the middle one, okay, we scaled our y-axis to 1,000 so that this time waveform also scaled to 1,000. And the third one, well, we could compare them across each other. So we're not just listening qualitatively to what we're hearing in the headphones, we're looking at all of this energy that's being created by the defect. Now, what's important is to keep in mind is what we call the inverse distance law. And the inverse distance law says that if I double the distance that I am away from the defect, then the signal is going to half itself. And if I half the distance, then the signal is going to double itself. Well, for consistency's sake, all that means is that if I'm scanning this one, and then this one, and then this one, the distance that I'm standing away from them needs to be uniform for this time waveform, for the 3 time waveforms and the signals to be comparable. And then we were able to take that time waveform and bring it into the spectrum to determine, again, these consistent peaks tell us that it is corona discharge. It's not an arcing situation or a tracking situation. Sometimes we can't get access to inside the panel. Sometimes we don't want access inside the panel. So as I kind of described before, we use a contact sensor, just the way a doctor listens to your lungs or your chest or your heart. And we're listening to the insides of this MCC panel. And we'll map it out. We might take a measurement here. We might take another measurement here, and then on this one, and then on each one of these. And we're mapping out the decibel level that we get. And so in this particular case, the high point or the most noise was coming from this part of the MCC cabinet. So what this did is it enabled us to put our focus into here. We didn't need to open them all up. We just need to open up this one because that was the loudest point. Once that was opened and the defect was eliminated, we closed it all back up again. All of these values went back down to a more normal uniform level. Okay, and here again, it's the time waveform on the top, 5 seconds. And if we pull it down into the spectrum, now we see those 60 hertz peaks, 60, 120, 180, 240, etc. And so again, very indicative of corona discharge. A 2000 kVA transformer, it's a pretty common medium voltage distribution transformer size. You'll often see them used in large commercial facilities, say hospitals, data centers, shopping centers. You might see them in light industrial plants, light manufacturing, petrochemical mining. And you might even see them in utility substation feeding larger loads or multiple buildings. Not just the noise from the transformer, but the whole transformer itself was very noisy. And infrared scans showed hot spots as well. So here's a great example of where we combined the power of thermal imaging with ultrasound to not only confirm a diagnosis, but to isolate and localize where the problems might be coming from. So acoustic imaging, this is one of the new toys or new instruments that have come out in the market. So really what's happening here is we're taking an array of ultrasound sensors, hundreds in some cases, and we're putting them in a cluster onto an instrument and then calibrating that to a camera, much like a camera that you'd have on your smartphone. And so now what we're able to do is we can take an image. So if we look at this image of this pole here, and we can see from this burst that our acoustic imaging camera is picking up a burst of energy from that insulator. Now, what that's telling us is that these other insulators are fine, but this insulator has some kind of a breakdown issue. And we can look at the PRPD, or the phase resolved partial discharge illustration of that and determine what type of failure it is. Here we know it's corona. Here it's because this is sort of extended out a little bit longer. And here it's called phase resolved because we're looking at the 90-degree phase and the 270-degree phase of the entire signal. But when it's drawn out like this, it tells us it's a little bit of more of a floating discharge than a specific discharge. And it's not uncommon even just to see right in the middle of the line. So this is indicative of some bird caging going on the cable. This is a breakdown of the actual cable sheathing itself. Okay, here we have some ultrasonic activity going on at both of the right and the middle phase of this transformer. But we can see by the coloration of the burst, when it's red, yellow, green, and blue like that, the burst, this is the more significant activity is coming from the center phase. Again, here's another, just shooting a substation with this acoustic imaging camera. And so, like I said, the phase resolved partial discharge, or the PRPD, we can see when it's corona partial discharge, we just see at the 90 degree aspect of the phase. If it's surface partial discharge, we'll see both at the 90 and the 270. And then if it's a floating partial discharge, we're going to see the same pattern, but it's going to be extended out. These acoustic imaging cameras, they're quite good. They're distance-wise, the one that we make, it's capable of detecting sources of partial discharge that are as far away as 200 meters, probably further than 200 meters. They work really well in 20 to 50 meters. They're not really designed for close-up inspections, so I wouldn't use it around switchgear panels, but substations, transformers, transmission distribution lines, that's really what they're designed for. Because they're just detecting airborne ultrasound, they're also a wonderful tool to use for finding sources of compressed air leaks at far distances. So just wrap everything up. I mean, I think when we have a presentation like this, where I'm describing a standard, I'm describing a technology, really boils down to what to do next. And what to do next can sometimes be answered by, well, do you have an ultrasound program? And are you following NFPA 70B? At the heart of NFPA 70B is safety. Every inspection, every maintenance action, and every procedure has to start with protecting people first. The findings from our inspections are only valuable if we use them. Turn that data into clear, consistent reports that drive action and demonstrate compliance. I said my focus is on ultrasound, but throughout this presentation, I've emphasized using and combining complementary technologies. So use both ultrasound and infrared. NFPA 70B doesn't say use just one technology. It doesn't just say use infrared, or doesn't just say use ultrasound. It says recognize multiple technologies and build multiple technologies into your electrical maintenance plan. Ultrasound and infrared complement each other. Together, they provide a fuller picture of electrical asset health. Establish clear procedures. Define exactly where to listen and how to perform inspections and which test locations should be marked. Consistency is going to build reliability. And obviously, always wear your PPE. Never compromise on safety. Proper personnel, protective equipment is not negotiable. If you haven't already done it, purchase the standard, review the most current standard, the 2023 standard. Make sure your team is working from the latest edition. The 2023 update turned guidance into enforceable standards. Update your internal procedures. Bring your own procedures into alignment with NFPA 70B so your practices are matching industry expectations. And condition monitoring of critical assets will ensure your most critical assets are enrolled in a condition monitoring program. And it's really up to you to define what's critical and what's not critical. But for me, criticality boils down to if I lose an asset, what's the impact? Again, going back to the hospital example, if I lose a transformer, I might lose lives. In manufacturing, if I lose a transformer, well, I know that some transformers, the delivery time on them is anywhere between 12 and 18 months. So imagine yourself not being able to manufacture your product for 18 months while you're waiting for your OEM to supply you with a replacement transformer. So define criticality however you want to. I don't define criticality by the cost of the asset. I define criticality by the impact of not having that asset available, not having that asset reliable. What's that impact going to be on me and my organization? And then finally, implement and document an EMP. Formalize your electrical maintenance program. Document it, implement it, and live by it, because that's the pathway to both compliance and reliability. And if that doesn't matter to you, well, document it and implement it anyways, because if you're inspected, if you're audited and you can't prove it, there could be stern fines, there could be disciplinary implications. That wraps up this presentation on NFPA 70B on ultrasound and maintaining safe and reliable electrical assets. I'm happy to field any questions if there's any out there. And if not, well, you can reach me by the email that's showing on the slide here. Generic hear more at sttultrasound.com. If you want to scan the QR code, that will bring you to our company's LinkedIn page where you can learn a little bit more about our people, our products, and just follow us. Our social media content is really driven a lot through LinkedIn. I call LinkedIn's Facebook and Instagram for professionals. So thank you for your attention and this opportunity to share my area of expertise with you all.